All right, so today we're going to be going over the Rocks and Minerals unit. And we're going to go and we're going to look at the back of our unit organizer on our expanded map. So now, what we want to think about, what were the important things that we talked about with each of our different categories? So minerals was our first category. And when we talked about minerals, we talked about several things. First, how do we know it is a mineral? So one thing we're going to look for would be the different characteristics of a mineral. It has to be solid, inorganic, meaning it can't have ever contained living material. It has to occur naturally, so we can't make it ourselves. It has to have a chemical composition, meaning it's made up of atoms. And then it also is going to have a crystal structure. So that means it has that repeating pattern we talked about when we were talking about crystal with our vocabulary. Now, how are we going to figure out what they are? Some of the ones you want to keep in mind when you're studying: luster, the way light reflects off a mineral. Hardness, does it scratch easily, like a 1 would on the Mohs hardness scale, or is it more of a tough mineral to scratch? Diamond is a 10, and that's the toughest one we would scratch. And then streak helped us in lab. We use that to find the color of the mineral when rubbed across a porcelain plate. So the streak can help us identify what's inside of it. And then we also use some special things like cleavage and fracture. Cleavage is when it breaks flat. Fracture is when it breaks jagged or curved even. And then you also had magnetism and taste. Magnetism would mean it attracts a magnet. Taste being if it had a salty taste like halite does. And those are some of the big ones that we used in lab. Another one thing you want to consider with a mineral are how they form. So don't forget when you're studying to take a look at how they form. It either forms from magma or solution. Those are the two ways. Magma would produce an igneous rock, which contains minerals that we could look at, and solution, which would be a chemical rock formed in a sedimentary category. So those are the two ways that minerals are produced. And the last thing you want to remember when studying minerals are the different mineral groups. Don't forget, silicates are the ones that are most abundant. So silicates are going to want to take some time when you're studying. Silicates, oxides are your ores, and then carbonates are the ones that react with our CO2, releasing CO2 gas when they react with acid. That would be the one that's more important. So those are your minerals. Now, there are 14 questions on the test that include minerals. So you want to make sure you take some time and start thinking about how those could be worded into test questions. Now, after minerals, we talked about igneous rocks. And igneous rocks form from the crystallization of magma. So they form that way. That's the only way you can get an igneous rock. So if you don't have crystallization of magma or lava on the surface, then you can't have an igneous rock. Now, I just said magma on the surface or underneath the ground. So that means there's two different types based on where they form. The first one is extrusive. Extrusive means it formed on the surface. Now, if it's on the surface, does it form fast or slow? Well, the answer is fast, because it's going to cool off much, much faster than it would below the ground, where it still keeps in some of that heat. So it cools quickly. Now, when it cools quickly, it doesn't have time for those atoms to get those pretty arrangement of patterns. So you're going to have a fine grain or a glassy texture. And that's going to be our extrusive igneous rocks. The other type of igneous rocks would be intrusive. So intrusive igneous rocks are the ones that form below the surface. So they're going to still be kept pretty warm, which means they have more time. They're going to cool quickly. So slow forming minerals, which means they have big chunky crystals or coarse texture that make them easier to pinpoint. You can see the different minerals that make those up pretty easily. Now, with extrusive and intrusive, let's not forget, we also have to consider that they could have silica or not so much silica. So if they have a lot of silica, that's called felsic. Felsic are the ones that are high silica and light in color. So those are the ones you want to keep in mind when you're thinking of continental rocks. But now, if they form in the ocean, they're generally mafic. Mafic meaning dark colored and low silica, but they're high in iron and magnesium. And iron is Fe and magnesium is Mg. That's the chemical formula. So it's high in iron and magnesium, low in silica, and that makes them dark colored. So those are your different igneous rocks that you want to consider when you're studying for the test. Now, is there anything else that you can think of that we might want to think about when we think about igneous rocks? We talked about their texture. We talked about what's in them. That word for what's inside of a rock is called composition. So composition plays a pretty big role because that tells you what minerals are in the rock. On the test, you have to be able to use that chart and look at composition. So take a good look at composition and knowing what type of rocks are inside each of our igneous rocks. Now, sedimentary was the next category. So how do you take an igneous rock and make it sedimentary? Well, you're going to have to break it into pieces. So sedimentary rocks, they form from a variety of ways depending on what they are. But the most common one from the rock cycle is weathering and erosion, breaking them down into sediments that are then compacted and cemented into sedimentary rock. That whole process is known as lithification. But let's start with the types. We've got organic. Organic are the ones that form from living materials. Then we had our chemical. Chemical are the ones that form from solution. So they're from solutions that evaporate and leave them behind. Then our traditional one was clastic. And that's the one that we just said was weathered and eroded. So it goes through weathering and then erosion. And then those sediments are going to be compacted and cemented into our sedimentary rock. Now we did that with a Rice Krispie treat in class. We compacted it and cemented it with our marshmallows to make a clastic sedimentary rock. So weathering and erosion, compaction and cementation, all of that's called lithification, and that's a vocabulary word as well. That's one word that you'd want to keep in mind when you're thinking of sedimentary rocks. So we have organic, chemical, and clastic. Those are the three main types of sedimentary rock, and the most important things we want to keep in mind are how those rocks form. And then you may want to take a look at your frame and look at some of those places that we'd find those sedimentary rocks and things that we might associate with the sedimentary rock. Some of our nice vocabulary words to keep in mind are graded bedding, meaning it gets bigger or coarser grained as you go further down on the rock. And then you have cross bedding, which means that there are angles, it's inclined as you look at the rock. The layers are inclined against each other, so it kind of makes a crisscross pattern. So those are sedimentary rocks and the types of things you'd want to remember when you study for the test. So then how do you take a sedimentary rock and change it to a metamorphic rock? Well, you'd have to use two main components, and those main components are heat and pressure. So heat and pressure are going to change the crystals inside the rocks and change them in such a way that we call it recrystallization. And that's going to form our metamorphic rock. Now, don't get confused by the crystallization. It's not going to magma. If it ever melts completely and becomes magma, then it can only form an igneous rock. These metamorphic rocks are going to be buried pretty deep inside the earth and subjected to high temperature and pressure to change them without melting them. Now, when you're studying, there are not as many questions about metamorphic rocks as the others on the test, but you definitely want to remember your three types of metamorphism. So the three metamorphism types, can anyone think of what they are? Now, if you said contact was one, that's exactly right. Contact is when you have direct touching of magma to a rock, and that heat is going to change the rock. If you said regional metamorphism, that is also correct. Sometimes large regions are subjected to high pressure, like when mountains are building, and that's how you get regional metamorphism over a large area. And then the last is called hydrothermal metamorphism. Hydrothermal is when you have hot water that's going through the rocks and changing them with its extreme heat. And those are also going to be associated with volcanoes and volcanic activity, just like contact metamorphism. So those are your three types of metamorphism. And the last thing you want to keep in mind with metamorphic rocks are the two main types of texture. Non-foliated, I think, is the hardest for students to remember. Non-foliated means it has no waves or layers. So it's just a rock that's been recrystallized and it doesn't have any indication of it other than on an atomic level. And then you have foliated, meaning that's the one with the wavy layers. So wavy layers are the foliated. It's going to either be stripes like you'd see in gneiss, or it's just going to be layers like you would see in schist, phyllite, and slate. But both of those are the types of metamorphic rocks. So those are the two types it will change to as the rock itself changes. Now, as you bury it deeper, it'll get a higher grade of metamorphism, meaning it will change more and more and more until finally it melts and we go right back to an igneous rock that's forming out of magma. So just keep in mind with metamorphic, heat and pressure producing our foliated and non-foliated. So study these concepts and see if you can't come up with some way to remember them for the test. Now, our test breakdown again, you have 14 questions in minerals. There are 20 in igneous rock. There are 16 in sedimentary rock. And there are only 8 in metamorphic rock. So just keep that in mind when you're studying and trying to divide your time up evenly. Good luck.